Hi, my name is Liam Taylor-West. I'm a composer currently working with mathematicians at the University of Bristol. In the past, I've written music for orchestras and smaller groups of musicians, as well as for film and radio, as well as virtual reality experience. What I'm trying to do at the moment is see what sort of music could be written using the ideas being studied by the mathematicians at the university and share some of those ideas with you. The first thing I'd like to talk about is the idea of periodicity. Periodicity basically describes whether something repeats or whether it doesn't repeat. If something is periodic, then it repeats. If something is aperiodic, then it doesn't repeat. To help explain this, I'm going to start building some sequences of events and we can look at them and see whether or not they repeat. But before we do that, let's just think quickly about music. You might not think of music as being something that repeats, but the more you listen to it, the more you'll notice that there are elements that do, and that's a large part of how it's built. The other day I was listening to the album Cosmogramma by Flying Lotus. It's one of my favourite albums, and if you listen to the start of the album, you get this. Flying Lotus is really inspired by early video game music, and you get that sort of repeated levelling up sound, which you hear at the start. I can't replay it, but you get the idea. It's built out of these four notes, and then repeated over and over again. So you could say that that element of the music has periodicity. It is periodic. To help explain this, I'm going to create sequences of events and see whether they are periodic or aperiodic, whether they have repetitive qualities or not. The first thing I'm going to do is hit a button 10 times. Every time I hit that button, a light will turn on or a light will turn off. If a light turns on when I hit the button, I'm going to write down on. If a light turns off when I hit the button, I'm going to write down off. Let's see what happens. If we look at the sequence we've made, we can see that it's built out of the elements on and off, and the full sequence can be broken down into a repeated segment, on, off, repeated 5 times. We can say that it's a periodic sequence because it can be broken down into that smaller element, on, off, and on, off is known as the period of that sequence. The period is the thing that is repeated to create the full periodic sequence. Let's make another sort of sequence. This time I'm going to take a coin. I'm going to flip it and I'm going to write down how it lands. If it lands heads, then I'll write down H. If it lands tails, then I'll write down T. Let's see what happens. Looking at this new sequence, we can see that it does not repeat. There are bits within the sequence that look like they're repeating, but after a while the pattern is broken. This is known as an aperiodic sequence because it can't be broken down into smaller elements that are perfectly repeating throughout the whole sequence. There are periodic and aperiodic sequences around us all the time. If you wrote down what day it was every day for 35 days, you would get this sequence. This is a periodic sequence. It can be broken down into a smaller chunk. That is the chunk of 7 days that form the week. The full sequence can be broken down into a period of Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, happening 5 times to complete the full sequence. Let's make another sequence. I'm going to go out and stand in the road and write down the colour of every car that passes me. Let's see what sequence we make. Looking at this sequence we've just made, we can see that there are elements within it that reappear, but that the full thing cannot be broken down into a period. Therefore, we say that this is an aperiodic sequence. I'll give you one more example. this one another musical one. Let's look at the piano I'm sat down next to. You can see that there are black notes and there are white notes. And mostly, black note follows a white note, and then white note follows a black note. It goes white, black, white, black, white, black. Every so often, you get two white notes next to each other. Because of that, you can see that the black notes are grouped into threes and twos. You've got 3 here, 2 here, 3 here, 2 here, 3 here, 2 here. Each of these groups have 2 white notes next to each other on either side. So, if you went from the bottom to the top of the piano and counted the groupings of the black notes, you would get 3, 2, 3, 2, 3, 2, 3, 2, 3, 2, the whole way up. This is what we call a periodic sequence. It is the numbers 3, 2, that's the period, repeated the whole way up the piano. Can you think of other periodic and aperiodic sequences that appear in your day-to-day lives? Perhaps they're things that you experience around you, or perhaps you've created them for yourselves in the same way that I did with the light switch and flipping the coin. Try and think of 3 periodic sequences and 3 aperiodic sequences from your day-to-day lives. So, why is this interesting to me? You can think of music as being built out of sequences of notes that you have to play at the right time in the right order to make the piece. I don't know if you ever played a game called Guitar Hero that was around when I was younger. You basically had 5 buttons to press and notes would fall at you at different speeds and you had to hit the right note using the right button at the right time. That's sort of what music is. It's sequences, and some of these repeat and some of these are different. You have to learn them to play the piece. So let's try and make some music out of some of the sequences we've looked at today. Let's start with the days of the week. I've built this thing in a program called Max 8. I use it a lot to make music and other things. What you can see here are the days of the week, and here's a piano keyboard. Each day of the week is related to one of these notes. And given that the days of the week keep repeating over and over and over, the same will happen to the music. Let's play it. Okay, so it's not particularly interesting. You've just got those 7 notes going on again and again and again. You could pick different notes, but the point of the matter is you've only got those 7 notes and you've just got to keep on throwing them round. It doesn't make the best music, really. Okay, so let's look now at the cars. We had that sequence of cars that we saw as they passed in the street. So here's another max patch. We called these things patches. And here's our sequence of cars. So again, each car, each colour will have a note on this piano. But because of how they appear, it's going to jump around a bit more. Let's have a listen. Okay, not great. As you'll see, the sequence started repeating again. But if you were actually going to be stood at the side of the road, the sequence wouldn't repeat, would it? You'd have a different car coming each time. You don't know what car is going to come next. So you could call this a sort of random pattern because you can't predict what's going to happen next. So let's go back to this max patch. Let's try and change it a bit. Let's put in a random box. And let's replace that there. Okay. So now we're going to go a random sequence of notes based on what cars come up. So let's just hear this. Let's hear the music that comes out. Yeah, okay, again, it's not particularly good music, is it? So let's think about some of the most successful pieces of music. Ed Sheeran's Shape of You was one of the most successful songs in recent years, and it's actually built out of a repeated sequence of notes. The song goes like this, as you probably know. So, let's take a look at that sequence that is the underpinning of Shape of You by Ed Sheeran. If you wrote down the note names, so these are the pitches that he's playing, you get this. You get C sharp, E, C sharp, C sharp, E, C sharp, C sharp, E, C sharp, D sharp, C sharp, B. So it looks like you're going to get a periodic sequence. It looks like it's about to repeat. You've got, which you think might be your period. You get it 3 times, but then it changes, and it changes to right at the end. So what looks like it might be a periodic sequence, actually, if you look at just that, is an aperiodic sequence. But that sequence then repeats across the whole song. So you could say that the whole song is a periodic sequence, and the period of that song is that little snippet we just played. Let's do something else though. Let's look at the rhythm of that sequence. By rhythm, I mean how long does each note last? How long do you hold a note before you play the next note? To me, I would say that you hold the first 2 beats for a very quick 3 beats. 1, 2, 3, 1, 2, 3. And then the next one you hold for a very quick 2 beats. So put those together, it goes 1, 2, 3, 1, 2, 3, 1, 2. So you've got this 3, 3, 2 idea. Let's chain that together and see what happens. 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 3, 1, 2. Did you notice how, even though the notes changed, the 3, 3, 2 pattern stayed the same? So, what do we call that? We call that a periodic sequence. In the same way as the piano is made up from 3, 2, 3, 2, 3, 2, the rhythm of the Ed Sheeran song follows 3, 3, 2, 3, 3, 2, 3, 3, 2. I'd like you to think of a piece of music. This could be your favourite song, it could be a piece you've played recently, it could be something you discovered for the first time the other day. I want you to think about what elements of that music are periodic and what elements are aperiodic. So, as we know by now, that means what bits of that music repeat, like the rhythm in that Ed Sheeran track, and what bits of that music do not repeat, like the notes. I was talking about rhythm and notes, but you could look at other things. You could look at the lyrics. You could say, oh look, these lyrics come back again each time the chorus comes round. That's a form of periodicity. You could look at how the song is structured. It might have a verse and a chorus and a verse and a chorus. That might form a pattern. Look at anything. If I was to give you a hint, I would say that the drum beat is often a good place to look for periodic elements. Often that is something that stays the same throughout the whole song, while other things change around it. So yeah, pick up your favourite song. If you can't think of one, just go for the Ed Sheeran Shape of You and see what bits of that song repeat and what bits don't repeat. And then maybe compare with someone else and see what song they chose and how that relates to yours. In the next video, we're going to see why the sequences we looked at today emerged in the way they did. We're going to start looking at some of the sequences that interest the mathematicians at the University of Bristol, and we'll keep thinking about how they relate to music and what sort of music could come out of them. Thanks for joining, see you next time.